Bismillahirrahmanirrahim. Now we discuss the diffraction of water waves. Of waves around the sharp edges or corners of obstacles or slit is called diffraction. In order to make the learning of the definition easy, you can divide this definition into parts. First part, the bending or spreading of waves. Next part, around the sharp edges or corners of obstacles or slits is called diffraction. Now we will study diffraction. We have to generate plain water waves in the ripple tank with the help of the vibrator. Then we will place two obstacles in the path of the water waves and we will leave a small gap or slit between the two obstacles so that the waves can pass through it. You can see that on the screen of the ripple tank, after the waves passes through this slit, the straight waves become circular in shape because they will bend around the edges. Let us check that what happens if we increase the distance between the obstacles. Now you can see that in this particular case, this is the wavelength and this is the distance between the obstacles. You can see that the wavelength is very small and the distance is very large. In that case, if you see on the pattern of the waves after passing through the slit, they are almost same as they were before the slit, but just there is a little bit of bending here near the corners. So what is the condition for diffraction? If you want a clear diffraction, the width of the slit should be small. This gap should be almost of the order same as that of the wavelength. Only in that case you will observe a clear diffraction. If you will not follow this rule, then diffraction will be only a little bit around the edges. If the distance between the slit is more, the diffraction will not be that much visible. This is the screen or picture of the screen of the ripple tank where the original diffraction experiment is done. In everyday life, in oceans, diffraction is observed. Here, this is an ocean ripple tank where you can see. Statement is, what is the wavelength of the radio waves transmitted by an FM station at 90 MHz, where 1 mega is 10 raised to the power 6 and speed of the radio waves is 3 into 10 raised to the power 8 meter per second. Frequency of radio waves was given 90 MHz. Instead of mega, you will put 10 raised to the power 6. So frequency will become 90 into 10 raised to the power 6 Hz. The second thing given in the data was speed of the radio waves, that is 3 into 10 raised to the power 8 meter per second. This is how you will write your data. The next thing is required. And what to find? The required was wavelength. Here comes the solution now. Formula we will use, that is wave equation. V is equal to F lambda. Put the values. V equals 3 exponential 10 raised to the power 8 and frequency is 90 into 10 raised to the power 6. Keep lambda on this side, take the value to the other side. It is multiplied over here, it will be divided. After calculations, you will get the answer as 3.33 meter. So, what is the result? Wavelength of the radio waves is 3.33 meters.